Now we have 10 minutes question and answer session. Anybody have questions, raise your hand and tell who you are, who you want question to.
I'm Rick Keating. This is a question for Mick. Can you put a second skin over highly reflective glass and not affect the quality of this first skin?
Is it working? Yeah. No. It's going to have an impact, but it doesn't mean that it won't be workable. So it would have to be analyzed. Do I understand your question?
Yeah, and it's just that so many of the buildings that we will have to look at for retrofitting are 20, 30 years old, highly reflective glass projects, and they look fine now. They probably are fine. They don't look anywhere near as bad as Javits do, but we're going to have to do something about them. And then, in that they are reflective glass, and it's such a peculiarly sensitive material in terms of heat, and what you do with an outer piece of skin on it, and how it would affect that might throw you into complete redo anyway.
Yeah. Well, what you want to try and do is reuse as much of the existing system as you can. And even if you have to take the glass out, which might be a possibility, that would definitely be a factor. I mean, a lot of the really early stuff, the single glaze stuff, is body tinted glass, right? So that wouldn't present the same kind of problem. But there were a whole bunch of those highly reflective glass buildings that were built specifically sort of in the later 60s and early 70s, I think. I don't know. I really don't know the answer. I haven't seen anybody do it. It would be a problem. But what you would definitely want to do is use as much of the existing system as possible. If you have to replace that glass, if you can reuse the framing system, at least do that.
Jose Torero, University of Queensland. You have all alluded to a number of different aspects. We talk about structures, reducing materials, improving the facades, fire safety aspects, but it almost seems like when you're dealing with a retrofit project that the seamless integration of all those components is where you have the biggest potential gain. Can you please comment on that?
It's a good point. I mean, those projects that I illustrated, they're all done with damn good design teams working together to try and get the best set of outcomes, which is typically the best set of compromises in any one area to get the best overall solution. So it's just good design, isn't it? What you're advocating is to get the best outcome in a retrofit project is no different from getting the best outcome in a brand new project. It's really good integrated design team working hard together to reach some sensible objectives. I think quite often though the projects that we do, the objectives aren't well enough defined at the start. So we're sort of heading off on a journey quite often that's undefined in terms of where it might go. But anyway, that's what makes our jobs a bit interesting, I guess.
I think the biggest thing that I would contribute to that is when you're doing a retrofit, obviously you're often working with limited budgets, but you also need to just have a very mindful eye of the life of expectancy of all the different parts and components that you're bringing into it. And so if you're going to retrofit the mechanical system, but the structure, is it going to maintain the same useful life, or is that going to trip a seismic upgrade? Or even like when you're talking about the skin systems, whether you're just touching the glass or the frame around it. Any of those you have to look at the whole project, I guess, and all pulling those parts together. Life safety is probably one of the biggest things that comes up as a challenge. If we're going to increase the useful life of the building by 50 years, what are the fire codes today versus what they were when that building was originally initiated? And do you need to upgrade to current life safety codes? And it really does become a case-by-case basis.
I'm John Perry from Yuanda. We talked a lot, or all the panelists talked a lot about increased performance and energy, but the reality is so much of the facade is the image it presents of the aspirations of the owner of the building. Fundamentally, those aspirations change over time, so it's inconceivable to me that people will not dispose of the outside skin on a regular basis. Because it's all about setting the new aspirations for economic changes in cultures and societies. Given that, there must be a different challenge that needs to be set to the people in facades. And I think it's to do with what you do with the stuff you're throwing away. So we have to rethink that whole process of throwing away. So I'd be interested to hear if you share my view about the reality of replacement. It's the NIMBY approach, in a way. And if so, where do we need to push our research so that industry focuses on the reuse of the material that we wish to dispose of because that's what we want?
Yeah, I mean, absolutely. I mean, it's a complicated issue. Certainly with glass, for example, which is not recycled now, one of the possible solutions is technology, right? I mean, there's definitely, it definitely seems a solvable problem. It's not simple. It's not just a simple matter of stripping, the inner layer from a laminated glass, or the low E coating, or these heavy metal oxide coatings. You need an infrastructure too to pick up that glass, to bring it back to the float glass plant. You got to get buy-in from the float glass producers, which should be achievable because it makes the production of the float glass cheaper. So, it seems like a solvable problem. And in fact, Saint-Gobain in Europe is doing some interesting things in that respect. And I think ultimately that problem will be solved. Aluminum, okay? So we are recycling the aluminum, like on the Javits thing. But there's a lot of cost that's involved in that. And you start, the renovation, Don talked about the embodied energy that is, as we make our buildings more efficient, this embodied energy becomes a bigger part of the equation. And, we are adding to that embodied energy when we do the renovation, so these become major factors. Aluminum is a problem that way. It sucks up a lot of energy. Using less material is a great strategy. Using simpler systems is a great strategy. And and people like Don talked about the importance of the aesthetic element culturally, and Adrian Smith he's all about that, and a lot of architecture is about that. Maybe too much architecture is about that. I think that we're going to have to make a transition into a more sustainable future that is going to be we're going to have our icons there. We need them, and that's important. But I also think we need higher performance buildings that are readily adaptable, easily adaptable into a future that includes a lot of climate change factors and things that we can't even anticipate. One of the big terms now in this sort of evolving sustainability dialogue is resilience, and resilience is about buildings being able to adapt to and survive through these changing conditions that we can't even anticipate, So how do you make a building, how do you design high-rise buildings that, that are more adaptable to a future that we can maybe not even imagine, This is, I think, the way that we have to start thinking about these things.
I'm just going to pick up on one comment you said there on the resilience. How do we design some of our buildings to keep them adaptable? And I'll use a common challenge that I face on projects that we do here in China: beams versus flat plates. Where do you put the beams? Or do you put beams in? Or do you come up with building systems that maybe minimize those? And a big part of that is the flexibility or adaptability to the modification or change to that building in the future. And that part of that's technology. Part of that is just simply understanding the systems and acceptability of systems. But I think it's important, especially in the more prominent, the bigger the building, the more flexibility that you build into the frame from the beginning, to even, as you were showing on some of your projects, coming in and putting atriums in, having a building that you can deconstruct and reconstruct and adapt in the future. It's something as a minimum we need to think about. And then we need to make sure that there's a bones and a very basis for the building that is worth preserving, that we can adapt it.
Don, it's David Scott here from Lang O'Rourke. I really enjoyed your presentation, particularly about the carbon footprints, but I had a question. I have an interest on the longevity, particularly the seismic longevity. You talked about a 2% probability of failure of a tall building in 50 years. And my question is, do you think that there should be a lower probability for tall buildings compared to the rest of the building stock? And what's your perception of what Mick is saying, that we should be designing for 1,000 years? And what do you think of other countries like China, going for much lower probabilities of collapse and extreme events?
Very good questions. There's several parts to that question, and it is much of that is a decision I think that needs to be made on a location and location by society basis. My personal opinion is the bigger the building, the taller the building, the more important in prominence it should have, that we absolutely have to hold those buildings to a higher standard. Much of what I was showing is talking about the average building inventory, and in the U.S. we use these importance factors of a 1.1 or a 1.5 depending on the purpose of the building. But I think performance-based design especially is a place where you have a tool where we can go in and start playing with some of those, and for what is a bigger building, for a more prominent building, we can hold it to a higher standard. I think the issue, so definitely I support that, and the bigger the building, and whether that's just based on occupancy, whether that's based on national monuments and significance to the culture of a location, I think all of those things need to come into play. The idea of a 1,000-year-old building, I'm actually a fan, and maybe that puts us out of business on some of the work we do. We have to be smart on what buildings that happens with, though. And maybe not all buildings get designed to a 1,000-year criteria, but there are certainly buildings that we need to hold to a much higher standard. What I think most of that drives, though, is actually not even so much as pure structural design, it's urban planning. If we're contemplating buildings for 1,000 years, we're going to be much more thoughtful about where we build and how we build. And I think that is really key, is to planning our future, knowing where our future is going to go and controlling that versus our future just being imposed on us. And so I think both of those are really important topics.